Hey guys, Mrs. Dan's here. So I have this video set up so that you can fast forward to whatever question you need to see me doing. You are able to check your answers on Remind, but maybe you got some wrong and you were still unsure, so maybe by watching me do it, it'll be a little more helpful. So I will be doing each problem. Number one, you have to be careful since it's a difference. Remember, this one gets distributed, and here it's a negative one that's getting distributed. So the problem we're answering is really 3a squared minus 2a plus 5 minus 1a squared minus 1a plus 1. And then we combine our like terms. So the 3a squared and the negative 1a squared make a 2a squared. The negative 2a and the negative 1a make a negative 3a, and the 5 and the 1 combine to be a positive 6. 2a squared minus 3a plus 6, choice 1. Number 2, the sum of these two polynomials, if I were to write the problem, it would be 3x squared plus x plus 8. That polynomial, I'm putting it in parentheses so I could see it's a trinomial, is being added to this binomial. Now when we're adding, really you notice that it seems like we're just taking away the parentheses, but that's because it's a positive 1 that's being distributed. And then when we combine like terms, 3a squared, x squared I mean, and 1x squared is a 4x squared. There isn't anything like this x, and then 8 minus 9 is a negative 1. 4x squared plus x minus 1, so it's choice 1. Number 3, product means to multiply. So it's 3x to the 5th times 2x to the 4th, which is like 3 times x to the 5th times 2 times x to the 4th. If I use a commutative property, I want to do 3 times 2 first, and then x to the 5th times x to the 4th. If you have to write it out, you'll have x times 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 x. I can see myself writing it down even if I don't actually write it, and I know that I'm left with x to the 9th. So choice 3. On this one, I actually am going to write it out because there are some common mistakes. 3 squared is 3 times 3. 3 to the 3rd is 3 times 3 times 3. And 3 to the 4th is 3 times 3 times 3 times 3. There's a whole bunch of 3's being multiplied. It's 3 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 to the 9th power. Choice 3. Number 5. This is so important to pay attention to the words. There is something similar to this wording on your test. So when negative 2x squared plus 4x plus 2 is subtracted from x squared plus 6x minus 4, I'm subtracting this first polynomial from this second polynomial. So really when I write out the problem, I'm writing the x squared plus 6x minus 4 first, because from that I'm subtracting the negative 2x squared plus 4x plus 2. If I distribute the 1, I get x squared plus 6x minus 4. When I distribute the negative 1, I get a positive 2x squared, and then a negative 4x, and then a minus 2. Combine like terms, x squared and 2x squared is 3x squared. 6x minus 4x is a positive 2x. Negative 4 and negative 2 is minus 6. 3x squared plus 2x minus 6, choice 4. Some people are unsure of what this even means. If x doesn't equal 0, the expression x squared plus 2x over x is equivalent to. The only reason why they're writing x doesn't equal 0 is because you can't have a 0 in a denominator. We actually talked about it one day in class that you can't divide by a 0. You just can't. It's undefined. So they're just telling you, yeah, okay, this is not undefined. X is not a 0. So we learned how to do this in lesson 9, actually. It's a polynomial divided by a monomial. We rewrite it as x squared over x plus 2x over x, and then we simplify. So this is 1, and this is x. This 1, this is 1. In this first numerator, I have an x over 1, which I don't need to put, plus 2 times 1, which is 2. X plus 2 is the final answer. Number 7, which situation would always double the value of a squared plus b? This question, I guess, is kind of like a thought-provoking question. I first want to tell you that you really don't have to stress too much about this for your test, but I would like you to maybe think about wording and decide which situation would actually double it. So if we want to double this a squared over b, doubling it is multiplying it by 2. So I want my answer to be 2 times a squared over b, which if I simplify that, I really get a 2a squared over b. So one way you can think about it is choose some numerical values for a and b and go through each of these situations to see which one works. I'll tell you it's choice 4 that works, and I'm just going to show you choice 4 algebraically. If I take half the value of b and I'm given a squared over b, what I can write is that it's going to be an a squared over half of b. This expression is mathematically to this expression because remember that a fraction really represents division. So I can rewrite this as a squared divided by half of b, which is the same thing as a squared divided by b over 2. And you learned in elementary school that when you divide with fractions, you switch this to multiplication and you flip the second fraction. If I multiply this across, I'm going to get a 2a squared over b. But again, don't stress too much about that. But remember, thought-provoking questions are great. Number 8, which one is this equivalent to? I'm going to write it all out. This is 3 times 3 times 3 times 9 times 9. So one thing I can eliminate are these bases of 27 because I can get a 27 with this 3 times 9 and another 27 with another 3 times 9, but then I'm left over with this 3. So I really can't use a base of 27. I guess I'm using a base of 3. So actually I'm going to change this 9 into a 3 times 3 and change this 9 into a 3 times 3. So now I could see that it's equivalent to 3 to the 1, 2, 3, 4, 5, 6, 7th power. Choice 1. Number 9. So when parentheses are to the 4th power, I like to write out my parentheses 4 times. I don't take shortcuts because sometimes we make silly mistakes when we do. I'm just going to simplify that numerator. 2 times 2 times 2 times 2 is 16. X to the third, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So x to the third to the 4th is really x to the 12th, and then y to the 4th power. That's my numerator so far. My denominator. These parentheses in this case are really representing multiplication because there isn't an exponent on the outside. So I can think of it as 3 times x squared times 4 times x to the 5th times y to the 2nd. Use a commutative property and write it as 12 over x to the 7th, because it's 1, 2, 3, 4, 5, 6, 7, y to the second. I'm not done because now there are some things in common top and bottom. 4 divides into these numbers. I get 4/3. There is an x to the 7th in common with numerator and denominator. So that's 1. And this is x to the 5th. And then there's a y squared in common. So that's 1. And this is y to the 2nd. My final answer is 4x to the 5th, y to the 2nd, all over 3. Parentheses get written out twice. So this means -3 times y times x to the 3rd times -3 times y times x to the 3rd. Commutative property, -3 times -3 is a +9. Y times y is y squared. X to the 3rd times x to the 3rd is x to the 1, 2, 3, 4, 5, 6. You see how I switched the x and y? Really, I would have accepted it in any order, but typically in math, we like to do alphabetical order. So x comes before y usually, but again, the commutative property holds true. So the reason why we keep on writing out our parentheses twice is because of situations like this. We have to write these parentheses out twice to notice that it's a binomial times a binomial. We can multiply this using the distributive property, or some of you seem to like this box method. X minus 3 is the first binomial. X minus 3 is the second binomial, so I get x squared minus 3x minus 3x plus 9. I'm left with x squared minus 6x plus 9. Final answer. I get a trinomial. Area of a shaded region. Remember, you learned area of shaded region in 7th grade, and now we've been applying it to polynomials in algebra. You have to find the area of the large rectangle minus the area of the small rectangle. They're both rectangles. Actually, this one's a square if both sides are the same. But anyway, we do length times width to find the area. So the large one is 2x times 3x plus 1. I'm just going to stay with this for a second. I'm using a distributive property. You can use the box method if you choose. We get 6x squared plus 2x. I have to subtract away the area of the small figure. So I have to subtract away x times x. I'm subtracting away x squared. In this case, these parentheses really aren't necessary because that's just a monomial. So I'm doing 6x squared plus 2x minus x squared. Combine the like terms, and I get 5x squared plus 2x is the area of the shaded region. Remember, I like to fix my negative exponents. This really is a monomial times a monomial. I'm going to rewrite this first monomial as 4. I'm going to bring this x to the -3rd to the bottom so that the exponent's positive. I'm going to leave this z to the 2nd in the numerator. I'm multiplying it by -8 x to the 5th z. This denominator just has a 1. So again, there are a few ways you can proceed. One way that you're allowed to do it, since it's a fraction times a fraction, you're allowed to simplify any numerator with any denominator. I notice this x to the 3rd in the denominator will simplify with this x to the 5th in the numerator. Simplifies so that my denominator becomes 1 and my numerator is an x squared. In my numerator now I have 4 times -8, which is -32, x squared z to the 3rd power. I have a 1 in the denominator, but we don't need to write that, so here's my final answer. Now there is a question very similar to number 14 on your test. Joe and Jen went to the store to buy writing implements. They bought pens, pencils, and markers. They bought 5 times as many pencils as pens. and 3 fewer markers than pencils. This is important right here. If X represents the number of pens, so this is like back to let statements that you used in 7th grade, they're letting X equal the number of pens. I need to express in terms of X all of the writing implements. Before I could add my pens, pencils, and markers, I need to know some things that can represent pencils and markers. So I need something to represent the number of pencils, and I need something to represent the number of markers. So I'm going to go back and read. Right here, this statement helps me with some let statements. They bought 5 times as many pencils as pens. So 5 times would be a 5x, because if there are x pens and it's 5 times the pencils, that's a 5x. And 3 fewer markers than pencils. So they're comparing it to the pencils, and there's 3 fewer. So however many pencils I have 3 less. So now I have these 3 let statements so that I can figure out all of the writing implements. So I have pens, and that's being added to pencils, which is being added to markers. So really it's an x plus a 5x plus a 5x minus 3, and we combine like terms. I have 11x minus 3 is the number of writing implements. So it was a multi-step problem, and you have to show all of your work to get full credit. Number 15, product means to multiply. So a trinomial times a binomial. Oh yeah, multiplication, I could always use the box method. I'll put my binomial over here, and I'll put my trinomial over here. To be honest with you, it wouldn't matter if you put your trinomial down this way and your binomial along the top. You would get the same answer. So this is x to the third minus 3x squared, 2x, negative 2x squared, positive 6x, and minus 4. So I have an x to the third. I'm just going to combine these right here without rewriting it. So I have a negative 3x squared minus 2x squared, which is minus 5x squared. I can combine the 2x and a 6x to get an 8x, and then there's nothing like this, so minus 4 at the end. This is my final answer. Find the area of a square. Oh, so if I have a square, area is length times width, whose side is x plus 2. Oh, so here's a side of x plus 2, but it's a square, so all the sides are the same. So this is also an x plus 2. Oh, I really have to do x plus 2 times x plus 2. So you could do like this distributive method, or you could do the box method. Either method you use, if I were to fill that in, or if I were to distribute, I would get x squared plus 2x plus 2x plus 4. Try this out if you have to, if you don't believe me. Combine the like terms, x squared plus 4x plus 4. So the area of this square over here is really x squared plus 4x plus 4. Determine if the expression is a polynomial. So we know that there's lots of expressions in math. If you go back to your lesson 5, we have those typed out notes that's in your book where it explains that a polynomial has to have terms, and your terms will consist of like a coefficient and a variable with your exponent. But the key thing about a polynomial is that your exponent has to be a whole number. It can't be negative, it can't be a fraction, That's how you determine if something's a polynomial. So let's first look and see if it's a polynomial. Polynomial, yes. Polynomial, no. It is an expression that we can do things with, but we don't classify it as a polynomial because the exponent is not a whole number. Polynomial, yes. I'm just looking at the exponents. Polynomial, this is actually yes. So it's just choice B that's not a polynomial. It said if it is a polynomial, classify it by its degree and by its number of terms. So we're not going to classify this one because it's not a polynomial. Classifying by degree means look at the exponent. The exponent's 2. Again, look back at lesson 5 if you need to, if you forget your terminology. But in order to be classified with an exponent of 2, we call it quadratic. And classifying it by its number of terms, there are 2 terms, it is considered a binomial. C is the tricky one because we see here x to the third, but this y actually has an exponent of 1. Therefore, the highest degree is the sum of these numbers. The highest degree is a 4. And I wouldn't worry too much about classifying something where you have to add the exponents. Since it has a degree of 4, it's called quartic. And it has 1, 2, 3 terms, so it's a trinomial. Finally, this has a degree of 0, so it's called a constant. And it has 1 term, so it's a monomial. Number 18, what is the area of a square? So I need to draw that. Notice I like pause and draw before I continue reading because I got to get things clear in my head. I have a square whose perimeter is 16x. So perimeter means I added the sides. A square has all the sides the same. So what could have I added 4 times to get a 16x? Don't you agree it must be a 4x? 4x plus 4x plus 4x plus 4x turns out to be 16x. So I found what my sides are labeled. Now I could go back and find the area. Area of a square is length times width. So 4x times 4x turns out to be a 16x squared. The value of 4 to the negative second power. Remember, negative exponents are not negative numbers. Negative exponents are the reciprocal of the positive. This is 1 over 4 to the second. That's not the value yet, though, because it's written in exponential notation. So really, I have to evaluate this to get 1 over 16 for my final answer. Again, here's a place where they're saying, oh yeah, they're not zeros because we can't divide by 0. You know how I like to do this. I don't like my negative exponents. I fix this immediately. And now I see what I have. Actually, before I figure out what I have in numerator and denominator, I'm noticing I have something in common, top and bottom. There's an x in common. So I simplify it. And finally, my numerator is 4x y to the 5th z. Again, I'm just doing alphabetical order, over 5. Final answer, done. Product means to multiply. It's a binomial times a binomial. Whenever you multiply, you could always use the box method. If you like just distributing, you're allowed to do that also. But I'm going to fill in this box. And I have 8x squared. I can combine these to be minus 14x minus 56. Not 14. Sorry. I knew like I wasn't thinking right. I'm just double checking myself here. It's 12. Find x so that the product of negative 2/3 and x is 1. So I want to do negative 2/3 times x to get 1 as an answer. So I'm trying to figure out what does x have to be. I could just solve this equation. I could multiply both sides by 3, divide by negative 2. You did that last year in 7th grade, or maybe you learned multiply by the reciprocal, multiply both sides by negative 3 over 2, or you could just use your mental math. How will I get this to equal 1? Well, that would have to be a negative number, because negative times negative gives me positive, and it would have to be 3 over 2, so that I get like 6 over 6, which is 1. So there are many ways that you can think about this one. The sum of 2x minus 3 and what polynomial will equal 0? So it's like I have to combine like terms so that I get a 0. Well, don't you agree? I'd have to have a minus 2x in here, and I'd have to have a plus 3 here. So the polynomial is negative 2x plus 3. It's the only way it can add to be 0. True or false? And if it's false, show an example to prove that it's false. So polynomial plus a polynomial is always a polynomial. That's true. If I add something that's called a polynomial to something else that's called a polynomial, I will get a polynomial. My polynomial might have only one term when I add it. Might have 2 terms, 3 terms, doesn't matter how many terms. Remember, a polynomial is just something with terms whose exponent is a whole number. A monomial plus a monomial is always a monomial. This is definitely a false statement, because if I add 2x, which is a monomial, to 3y, which is another monomial, when I add those, I get a binomial for an answer. I get 2x plus 3y because I can't combine like terms. So a monomial plus a monomial can give me a binomial. A polynomial multiplied by a polynomial is always a polynomial. That's true. And then a monomial multiplied by a monomial is always a monomial. That's also true. Remember, the only way that I can get something, if I start with, let me say, a monomial is something without plus or minus signs, right? A monomial only has one term. So if I'm multiplying a monomial times a monomial, there aren't any plus or minus signs to begin with in the problem. So there's no way I could get plus or minus signs in the end. So that's why it's always true. Be careful here, the exponent of 0 only belongs to the 5, not to the negative, so this turns out to be a negative 1. The exponent of 0 belongs to the entire parenthesis, so this turns out to be a 1. The exponent of 0 belongs to the parenthesis, but there's a negative out in front, therefore this is a negative 1. And we've seen this problem a few times. Remember, I even have it up on my board. I made that orange rectangle surrounded by the white border. So we've done this quite a few times, which means I expect you to be able to do it for your test. So they want the area of the entire region. They want this whole thing. So pretend it's not separated into 2 pieces. Pretend it's not a pool and a walkway. Let's just imagine it being one big rectangle. To find the area of the rectangle, I have to do this whole length times this whole width. And we talked in class that we know from here to here is 14, but there's an x here and an x here. You add the pieces together to get 2x plus 14. And if this from here to here is 20, and this piece is x, and this piece is x, we add the three pieces together to get the whole length, which is 2x plus 20. I have a binomial being multiplied by a binomial. I could do the box method. I want to do 2x plus 14 times 2x plus 20. I get 4x squared, 40x, 28x, and 280. Combine like terms, 4x squared plus 68x plus 280 is the area of the entire thing. I guess that's everything. I hope it was helpful, and good luck. I'll see you tomorrow.